So just how we kind of noticed way up, way, oh my gosh, where is it? Just how we kind of noticed, like, way up here, way up over here. Sometimes we need to break stuff down. We need to find one part of a triangle in order to find another part of a triangle. That's kind of what this is. So this is the exact same stuff we've been doing. It's just, it's going to be multiple steps. It's 2 or more triangles. It's more complex, but the math itself is the same. It's just, we need to have a tactical approach here. So basically, our main goals of this topic now is we're learning how to break stuff down, how to break it down, and how to establish those steps in solving it. This is why for the last 3 weeks, we've been building an equation at the very top. In plain English, how do I solve this? Then do the math part of it. Here we go. So we're breaking the situation down and we're finding the steps to solve it. We might need to use values from one triangle to find the values in another triangle. So that's some stuff we started to get an introduction to earlier. Sometimes we're going to need to work with triangles that are on an angle to each other and share common edges. And the other thing we kind of need to remember is that a straight line is going to have 180 degrees. That will come into play a couple times throughout this. So some of those basic line facts are now coming into play. And we also know that triangles have triangles and lines both have 180 degrees as the angle here. So that's just some important information here. But so like I said, at this point, we're pretty good to be able to kind of do everything here. The one thing we really need is we need to, now I'm going to use word things. I'm going to use, we need to two sides / angles. In order to find anything on a triangle, all I need is 2 things, either 2 sides or an angle and a side. You just need 2 things of a triangle to find a third thing of a triangle. So whenever we're breaking down these problems, how do I solve this? That's all we need is I need 2 things. I need 2 angles or 2 sides or a combination. So let's break this one, this question down here. I'm just going to zoom in for a second. So I got this question here. It wants me to solve for X. It wants me to solve for Y with this. My question for you is, how could I figure out X? Just plain English. Tell me how would I do that? Do I have the tools I need to do that?
You got angle and you also got vert.
Yeah, I have 2 things in this triangle, so I can figure out X. Can I figure out Y right now? No. What do I need to figure out Y?
X. You need to figure out what X is.
I need to figure out what X is, or I need to figure out what the hypotenuse of this is. I need to figure out one of those 2 things. I need a side. You need a side. So realistically, though, it sounds like I need to figure out this X first, because then I have 2 things to figure out Y. So it's going to make sense now. We're going to find X first. And to find X, I'm going to use this triangle here, the one that I'm just highlighting in red. And so as we've established, I have 2 things. So again, I'm just writing future me a note. This isn't an equation anymore, but I'm just writing future me a note. It's complex problems. Find X and use it to find Y. You don't need to do this, but it's a helpful thing to do as we get to more and more complex problems. So let's find X. Let's label my sides. At this point, we should be pros at this. I know that this one over here is going to be my opposite. Here's my right angle, which means X is my hypotenuse, which means 6.4 is my adjacent. And what 2 sides have something attached to them? Well, so which 2 sides? It's adjacent, and I'm trying to find the hypotenuse. So what do I have? I have A and H.
So cosine.
Yeah, I'm going to use cosine, right? Because it has that. You don't need to write the SOHCAHTOA down. I'm just doing this just to kind of reference that. All right. So I know I need to use cosine to find x. So let's do that. So the cosine of the angle, which is 40, which is 40 degrees, is equal to, it says adjacent first, so 6.4 meters, all over the hypotenuse, which we've already called x. We've already called that x. So right away, I see that x is on the bottom of my fraction. When it's on the bottom of the fraction, what do I got to do? I got to times by x, right? I got to times both sides by x. I'm using the dot to show that I'm times in because it's really weird to go x, but if it works for you, it works for you. That's fine. But we're going to start seeing that more often, that dot.
Question I have is
Mhm.
type of route. So do we have to do that? If we already know how to do that?
You do not. No, you know, as like a math teacher, like I'm kind of forced to do it. But like when I was a student, I personally didn't. But as long as you understand like what that, like that 40 is attached to it right now.
Oh,
Yeah. Yeah, I'm not going to dock you marks if you don't. So that cosine of 40 still comes down, but it's still being times by x. But I'm just going to be left with 6.4 meters. And you're going to notice I used to do the arrows, this, you know, this times x thing on both sides. I've stopped doing that. Because at this point, you know, we've done it a whole bunch of times. I'm just using that to show that you can pretend it's on this side as well, but I'm not expecting you guys to do that every single time or at all. Yeah.
Follow-up question with that as well. For a couple of my questions, I stopped using the lines entirely, but it showed what was happening.
Mhm.
Is that fine if we don't put the lines?
If you don't put the lines, that's fine. Like,
Lines was showing-
yeah, as like you could just go straight from like here, if I just erase it. Eraser. Yeah, like just that itself is fine. Like I'm gonna like know that, oh, you times it by x. Like you could cross this out, you could put the lines on both sides, and that is fine. But if you don't do that, as long as it's like correct, like I'm gonna be able to interpret what you've done.
Yeah, okay.
Yeah. As long as it's laid out like in a, you know, at least semi-organized fashion. All right, and so now I have x on top of the fraction. What do I need to get rid of? I need to divide, and what's it? Yeah. So right now, cos is being times into x, which means you need the opposite, and I need to divide it. And again, I'm just putting the lines here, but eventually today I'm gonna not do that. So divide by cos cancels out. I'm left with just x is equal to 6.4 meters divided by cos of 40.
We skip that stuff, like, is that fine too?
I would say that'd be fine too. Like again, if I like seeing where'd you start, would you do something in the middle, and then if you just go straight to the answer, I would probably still accept that. Yeah.
Like what I'm talking about,
Oh.
like, like what I used to do is like cosine 40 equals 6.4, and then I just immediately go to 6.4, divide that by cosine.
Yeah, that'd be fine. Yeah, as long as I'm seeing like some like partialness in there, that's fine. So I'm just gonna punch on my calculator. So 6.4 divided by cosine of 40. And I should get 8 point. So x equals 8.36 meters. I'm gonna underline that because that's important. Actually, I'm gonna circle that because it's asking for two things. So it technically is a final answer. Now this is where some people, what they really like doing is, some people like going into their triangle on their chart, and they like writing that in. You're welcome to do that. That's totally fine. If you want. It's not a mandatory thing, but you now know that this line, this X line is 8.36 meters. And we already established right before we even did any math, now that I have X, I can use it to find Y. So check, now I can use it to find Y. Now, if I'm looking at this other triangle, again, this one I'm drawing in red here, I now have two things. So I have this side, this opposite side. And I'm trying to find my adjacent side. So what uses O and A? Tangent. So now I need to use TOA. So now to find y, again, you could write y like this if you want. You know, you could have y there, you could do y underlined, you could just not have it at all. I'm personally going to go away with it. So TOA of the angle, my angle is 68 degrees. Oops. Is equal to opposite over adjacent, right? TOA, opposite over adjacent. So 8.36 meters all over adjacent, which we've said is y. And just like before, I can see that. So the mathematical word we use for that would be variable. But that's the fancy way of saying the X, the Y, the A, the C, whatever it is you're trying to find. The thing I'm trying to find is on the bottom of the fraction. So what do I have to do? I have to times, right? So now I need to times both sides by Y. I'm not going to write the arrows this time. You can if you want. But I'm going to times both sides by Y, and I should end up with TOA of 68 times Y is equal to 8.36 meters. And so now what do I need to do? Yeah, well, why did I write TOA? Tangent, yes. What did I write TOA there? Whoops. So now you're right, I need to divide by tangent of 68. And you're gonna notice what I've been doing is I've been kind of get the equal sign in the same place, get the variables in the same place. You don't have to do that, but I find it's quite helpful to like understand what's going on as you come back to it later on. Like that's why I move my equations around like this, just to kind of keep things in the same way, in the same order. All right, and then pretty simple, just punch in our calculator, right? Calculator does all the heavy work for us. We just have to set it up right. So 8.36 divided by tangent of 68, I should get y is equal to 3.37 or 38. 38 meters. It's a final answer. I'm going to circle it. Am I done?
Yeah.
Yeah. You could write a statement if you want. X is this, Y is this. You've circled it. I can find it. If I can find it, it's good. Don't just leave X up here uncircled. Like, make it easy for me, please. Or you can do a statement. That's fine. But this is fine. You've answered the question fully, right? It wanted you to find X and Y. I found X. I found Y. You can write a statement if you want. I'm not going to penalize you. I never did it as a student. So now, the one thing we kind of struggled with a couple days, what is today, Tuesday? So I think that was Friday or something, was word problems. It is so much easier when I have a drawing, right? But it's a skill we kind of need. Specifically, this is a skill that's setting us up for success for next math class. And by that, I mean in block 3. So it's a skill we need to acquire, and it's going to take some practice. So what I like doing is I like going in and underlining or highlighting keywords. So I have a flagpole that's supported by 2 wires that are each attached to a peg that are in the ground 4 meters from the base of the pole. Sometimes we're going to need to read this question over a couple times before we get an idea. The wires have angles of elevations of 35 and 45 degrees. And it wants us to know how much higher up the flagpole the top wire is attached. So let's break this down. So I'm gonna reread the question. So what is it? What do I have? I have a flagpole. Have you guys ever played like the old school like Mario games? Yeah, that's why I have the flag. That's the only reason I have that flag up there. You could not have it, but I'm just showing, hey guys, it's a flagpole. So I have a flagpole and it's supported by two wires. And those are each attached to a peg 4 meters from the base. So what do I have is I have a peg in the ground on both sides. So here's my ground. They're both 4 meters away from the base of the pole, right? The bottom of the pole. And so those wires, like you've probably seen stuff like this, right? It's wires to keep it steady in the wind. So one of these wires is higher than the other. I know that because it literally says it in question A. So I have these two wires here, right? One of these wires has an angle of 45 degrees. The other one has an angle of 35 degrees. Now, does it say which one has 45 and which one has 35? No. So that's why I'm just picking. If it told me specifically, hey, the taller one had 45, I'd have to do that. But it's just telling me you have two wires, they're the same distance away, so you can just pick whichever one you want. That's fine. So with a diagram, okay, I can start to approach this problem a little bit more. And one thing I really quickly want to talk about, you notice here how it says the angles of elevation? So we have two angles, right? We haven't talked a whole lot about this, but when you have an angle of depression, when you're depressed, usually your head's looking at the ground, right? When you're elevated, you're looking up. So it's the angle is looking up towards the flagpole. That's why I know it's there instead of these two yellow regions, because it's looking up, it's elevated. Uh-oh. There we go. Okay, so now we're prepared to actually answer the question. So the question wants to know is how much higher up the flagpole is the top wire attached? So what does that mean? How much higher up the flagpole is the top wire attached? What am I trying to find here? So, oh, sorry, two people talked. Ravon? The which on both sides? Oh, the Y on both sides? So again, let me know if I'm wrong here. You're saying like how tall each of these triangles are? Okay, and Evan, you were saying the elevation? Elevation of what? Of the wires? Okay, so you guys are both saying the same thing. Hey, we need to find the elevation of these wires. So that is one way to do it. You're absolutely right. So you guys are right. We're approaching this the right way. Why don't I figure out how tall this one is? I'm going to call that X. And then how tall this one is. And then can't I just take X and take away Y? Can't I take the taller one and can't I take the bigger number, take the smaller one, and then I'm left with what I really want to find, which is, I'm going to call that Z. That would work. That's what we're saying, right? Hey, we find both these heights. We just need to find the difference of them. How much higher up is the flagpole on the top guy wire attached? I need to try and find Z. I'm just labeling it Z. You could label it. You could do A, B, C if you wanted. You could say thing 1, 2, and 3. That's fine. 2, I wouldn't probably put numbers in there. That's going to mess you up. But what have I done? X minus Y equals Z. I just made my equation. I just did it right there. So now I have my reference point. I can always go back to that. So is that making sense, like how we're approaching this? Again, we had to read through that question like 3 or 4 times to do that, and that's fine. So all of a sudden, okay, I think I know how to do this. This word problem's a little bit less intimidating now. So why don't I find X? I'm going to find X first. I'm just going to write a little X here. I'm going to underline it. That's so I know that's what I'm working in. So someone walk me through. What do I do now?
Label the triangle.
Label the triangle. So what's the X going to be?
That would be the
Well, so we're just labeling the sides.
Opposite of the X.
Opposite's X because it's opposite of this angle. What's this side? Hypotenuse, which means our 4 meters down here is the adjacent.
I thought the X had to be on the other side.
Oh, I see. Yeah. So X is the left side of this flagpole. Y is the right side. Again, you might call this left and this right too, like L and R. There's a bunch of different ways we can approach it. But yeah, so I've labeled it. So I have the opposite and I have an adjacent. You're right. It's going to be TOA. So tangent. So I know I need to use tangent. What's the angle? Yeah, we said 45. We're not 100% certain. Now let's think about that for a second, actually. And either way, it's not going to matter which size of the flagpole is right, but I put 45 degrees there for a very specific person. When you're 45, is 45 degrees steeper or like 45 degrees is going to be a little bit more steeper, right? So it's going to have the line's going to go higher. If you didn't do that, if you didn't think that through, that's okay. Like it's not going to change your answer. Either way, you're figuring out how much higher one wire is than the other. Doesn't matter which one's on which side. If it matters, it will tell you. Or it'll give you like information that matters for that. So tangent of 45 is equal to the opposite, which is X, divided by 4. Thank you, because I could not remember. Okay, X is on the top of a fraction. So what do I have to do? I'm going to multiply by 4, right? I need to do right now, X is being divided by 4. I need to do the opposite, which is times it by 4. So I'm going to get tan of 45 times 4. Actually, I'm dealing with an X, so I'm just going to put the little circle is equal to X. And then what do I do? Well, is an X by itself? Yeah, I only have to divide. I'm only going to do a 2-step if X is on the bottom of a fraction. But because X is on the top of a fraction, I got rid of that 4 already on that one side. So now it's just X by itself, which is what I want, right? So now I can just punch that in my calculator. Tangent of 45 times 4. And what do you get as an answer? 4. Now, this is probably throwing off some alarm bells in your head because you're like, where's the decimal? If you take tangent and just tangent of 45, you're going to get 1. So this actually works. That's the right answer when you see this 4 here. Most people are like, that doesn't seem right. But yeah, it's 4 meters. So I'm going to underline that. That's important. I'm going to check my X. I'm done that. So now what do I do? Sorry? Find Y. Yeah, I'm going to find Y, which means I'm going to label the side of it. So at this point, we should be pretty good with like labeling the sides. I should know that the Y is going to be my opposite. This unknown side is my hypotenuse, and then the other side's my adjacent. It's set up the exact same way, just a little bit different numbers, right? Sorry, I'm a little quick there. So I've got tangent of 35, because that's my angle, is equal to the opposite, which is
X.
well, Y. Yeah, but yeah, I know what you're saying. Yeah. which is y, and that's all over the 4 meters again. And just like before, just like the one from x, well, my y is on the top of a fraction. So what do I have to do? I need to multiply by 4. So I'm going to get tangent of 35 times 4 meters is equal to y. And now what I end up getting here is I do get 2.8. So y is equal to 2.8 meters. Underline that, that's important. Okay, and we have to thank previous us here. Well, now I know how I can find how much higher up the flagpole is, which we called Z. Like that's where I got that from. That's the difference between these two. So I can just take X, which is 4 meters, take away Y, which is 2.8 meters, and that's going to give me my answer, right? So how much higher up is this flagpole? 1.2 meters. That is my final answer because that's what it wanted. So now I can circle that. I underline the important stuff that is not my final answer, and I circle my final answers. Okay. So this next question down here asks us, how long is each wire? Now, how could I figure that out? So this is still part of the same question up here. So what's it asking us to find? The hypotenuses. How can I find the hypotenuses? I could use Pythagoras. Now, I could also use trigonometries too, because you have an angle and a side. I have two sides and I have an angle. I can use any method now to find anything I want. So you could either use Pythagoras, you could either use trigonometry. There's so many different ways. So what I'm going to do is I'm going to give you guys about 3 or so minutes, 3 to 5 minutes to try and answer this. I'm going to come walk around in a minute and see how we're doing. If it's helpful, you can quickly draw your diagram again. That would be fine if you want to do that. I know that's 4. I know that's 4. I know this is 4. I know this is 2.8. That all I'm doing is I'm just redrawing my diagram. That's 45. That's 35. So I'll give you 5 minutes here to try and find that information. You can use any method you want. I'm going to walk around in 1 minute because I did not do attendance.
Pythagoras, okay.
Oh, the 32 square thing though. Was it, I don't know, what square root is it, like? Oh, I think you square root 4 squares, then you square root 16. I mean, that would make sense. But your calculator's keeping wrong, you set it up right, the calculator's keeping wrong. Yes, instead of 2, 1, 3, it should be that.
So it looks like everyone was on the right track. What you should end up getting is you should end up getting, one of them is 4.88 meters. And then the other one was 5.66. And again, you can use Pythagoras or you can use trigonometry for that. Either one of those works. But it looks like everyone got that, which is good. Like these are hard questions, so that's really good, guys. Oh yeah, hold on. Let me this next one's a doozy. You don't want to do that right now. We're gonna skip question 3 for now. We'll probably do that tomorrow. So we're gonna skip question 3 for now. We'll come back to that. So what we'll do is we'll let you guys just get straight into it. I'll let you guys start some of this stuff here. We'll see if we can do question 3. I want to bring an actual box and a rod for that because it just makes so much more sense. So I'll let you guys get straight into it here. Try out some of these at about 2:30-ish. We're not going to have a concept check. I'm going to give you your old ones back and you guys can go through. For the most part, you guys did really good on them. There was just one small thing that everyone had messed up on. And when that happens, I take it as a crap. I probably could have taught that better. So you're not going to get like punished for that or anything. You'll still get the marks because everyone did the right work. They just forgot one small detail. So we'll talk about that more later today. But for now, you guys got about an hour to try out some of these questions. They are not easy. Give them your best shot. The point of this is to challenge ourselves.